Hey everyone and welcome. We use our computers every single day for, well, everything, right? From sending an email to playing a game. But have you ever really stopped to think about what's actually happening inside that box? Today, we're going to pull back the curtain and break down the core parts that make it all tick.
Seriously, just think about this for a second. You tap a key on your keyboard, say the letter H, and bam, it just appears on your screen. Like magic. But what invisible, lightning-fast process just happened? That's the exact question we're diving into. You know, that one little key press, it sets off this incredible relay race. It's not just one component doing all the heavy lifting. Nope. It's a whole team of parts, passing information back and forth along a super specific path, and they're doing it at speeds that are just mind-boggling.
Okay, so to really get a grip on all this, let's use a simple analogy. I want you to imagine your computer is like an incredibly efficient office worker. Seriously, this worker has everything they need. An in-tray for new tasks, a brain for all the thinking, a desk for whatever they're working on right now, a big filing cabinet for storage, and of course, a way to show you their finished work.
Believe it or not, everything a computer does boils down to these three basic steps. First, it takes in a command. That's your input. Then, it thinks about it, works on it. That's processing. And finally, it shows you the result, and that's the output. Input, processing, output. It's the exact same workflow our little office worker follows all day long.
All right, so first things first, how does our office worker even get their assignments? Well, they come from the outside world and land right in their in-tray. And for a computer, that's the job of all the input devices.
So what's an input device? Put simply, it's anything that lets us talk to the computer. It's how we give our office worker their to-do list, whether we're typing out a command or just clicking a mouse.
And you use these things all the time, right? Your keyboard and mouse are the big ones. They translate your physical movements into digital signals. A microphone, that turns your voice into data. A scanner takes a physical page and digitizes it. They all do the same basic job: get information into the system.
Okay, so the task is in the in-tray. Now it's time for our office worker to actually get to work. This is the processing stage, and it's all handled by what is probably the single most important component in the whole machine, the Central Processing Unit, or as we all know it, the CPU.
Yeah, the CPU is the brain of the computer. And that's not just a cute nickname, it's the perfect description. It really does control the operation of all the other components. It's not just doing math, it's the conductor of the entire orchestra, telling every other part what to do and exactly when to do it.
So how does this brain actually, think? Well, it's split into two main parts. First, you've got the control unit, or CU. Think of the CU as the manager. It reads the instructions and directs the whole workflow. Then you've got the arithmetic logic unit, or ALU. This is the super fast calculator part. It's the one that handles all the math and makes logical decisions, like figuring out if one number is bigger than another.
And this whole thing happens in a constant three-step loop. It's called the fetch, decode, execute cycle. First, the control unit fetches the next instruction from memory. Then it decodes it to figure out what it's supposed to do. And finally, it executes the command, sending signals to the ALU or other parts. Fetch, decode, execute. And here's the crazy part. This happens billions of times every single second. It's unbelievable.
Okay, but our little office worker can't possibly hold everything in their head at once, right? They need a place to put the files they're actively working on and another place to store all their completed work for the long haul. And that's where memory comes into the picture.
And this is where our office worker analogy becomes so helpful. I want you to think of RAM, that's random access memory, as the worker's desk. It's where they spread out everything they're working on right now so they can grab it super fast. Now your storage, like your hard drive or SSD, that's the big filing cabinet in the corner. It's for long-term safekeeping, but it's a little slower to go and pull something out of. This is exactly why adding more RAM, basically getting a bigger desk, can make your computer feel way faster when you have a bunch of programs open.
And here's the absolute crucial difference between the two. RAM is volatile. What does that mean? It means when you turn off the power, the desk is instantly wiped clean. Poof! Anything you didn't save is just gone. But the filing cabinet, your storage, is non-volatile. Everything you put in there stays put, safe and sound, even with the power off, until you decide to get rid of it.
All right, the work is done. Our office worker has followed the instructions, crunched the numbers, and has a result. So now what? Well, now they need to show it to us. And this brings us to the final step in our journey, the output. It's pretty simple, really. If an input device is how we talk to the computer, then an output device is how the computer talks back to us.
It takes all that processed information and presents it in a way we can actually understand, as text, images, or sound.
The most obvious one, of course, is your monitor, or your visual display unit. It's what shows you pretty much everything you're doing. A printer is another great example. It gives you a physical hard copy. And then you have more specialized things like a graphic plotter, which can create super detailed drawings. They're all just different ways for our office worker to present their finished product.
And there it is, the whole journey, from start to finish. You press a key on your keyboard. That's your input. That signal zips over to the CPU, which uses RAM to process the instruction. That's the processing. And finally, the CPU sends a new signal to your monitor to display that character on the screen. And that's your output. All of that in a tiny fraction of a second. So, what's the big idea here? The main thing to remember is that a computer isn't just a random box of parts. It's a deeply interconnected system. Every single click, every key press kicks off this incredible high-speed relay race inside your machine, where every single component has a critical job to do. So, I'll leave you with this to think about. Now that we've broken down the roles of the brain, the memory, and all the ways we talk to our computers, which of these fundamental parts do you think is going to change the most in the next 10 years? Is it going to be the raw power of the processor, the speed and size of our storage, or is it going to be the very way we interact with these machines in the first place? Something to chew on.